I don't know about you, but these days I feel like we get new big releases in the front-end space on a weekly basis. So, despite being always mocked by its ever-changing ecosystem and the constant hype train, the web dev world is more alive than ever. Anyhow, let's not waste any more time and talk about one of the big releases of this week. Qwik.js just reached version 1.0. I know, yet another JavaScript library. You probably grew tired of all of them by now. Hear me out though, Qwik really deserves your attention, and in the next few minutes I'm going to show you why. Compared with alternatives such as React, Vue, Svelte or Solid, Qwik is built and architectured differently from the ground up. To clarify this idea, we should probably define two important concepts slowly shaping in the front-end development space. On one hand, you have these things called UI libraries. Think of the likes of React, Vue or Solid. In short, these are tools allowing you to add interactivity on a static web page. These are the libraries which popularized the idea of single-page applications and, when used, will rely on client-side rendering to convert JavaScript objects and methods into DOM elements and event handlers. You probably worked with such tools in the past and got a chance to see them in action with both their pros and cons. And, speaking of these advantages, one of the main disadvantages of JavaScript UI libraries is, funny enough, their heavy reliance on JavaScript. Rendering HTML via JavaScript implies slow app loading times and worse performance over time. The second term we need to define is meta frameworks, the tools used to address some of the pitfalls brought up by UI libraries. Think here of Next.js for React, Nuxt for Vue, or Solid Start for Solid. Among other various benefits, these frameworks have one big task: alleviate the bad performance of client-side rendering by engaging the server in the process of converting JavaScript objects into HTML. Of course, once the HTML reaches the browser, the JavaScript still needs to be sprinkled in via a process called hydration, so you'll still get a couple of seconds when the app is visible but not interactive. This process is called the uncanny valley, but enough with the rendering theory. We are here to discuss Qwik, but if you're interested in details regarding rendering strategies, please check the video in the top right corner. So what makes Qwik so different? Let me explain. Instead of going the usual hydration route, Qwik employs an approach called Resumability, which, in short, means that at any point, an application lifecycle can be stopped, serialized, and moved to a different environment, either a server or a browser. Once the app is in the new environment, it simply resumes from the point where the serialization stopped. This is the cornerstone of Qwik's take on building full-stack apps. Yes, you heard this right, full-stack apps. Take a mental note because we'll get back to this one in the second part of the video. As you would expect, there are a bunch of other features and architectural decisions in play here. For instance, your app will get instant loading time since all Qwik apps are HTML first. This means that static HTML is sent from the server, and then the needed JavaScript is streamed to the client only when needed. This approach is combined with speculative code fetching and lazy execution so that the framework delivers only the JavaScript code needed, only when it's needed. Just like with most things in life, this is usually easier said than done. There is a lot of heavy lifting happening in the background to support this resumable architecture, and during the process, Qwik has to solve three problems: correctly attach listeners to static pages, efficiently rebuild component trees between resume processes, and reliably handle app state across sessions. For the past couple of minutes, you've seen me writing some Qwik components, so you should get a feeling about the dev experience by now. The code should look pretty familiar, especially if your background is in a library such as React, since Qwik uses features already accepted by the front-end community as established solutions for various problems. So, in here, you'll have function components to group together related code and business logic, hooks to handle effects, state, or the lifecycle, and JSX for templating purposes. One big difference compared to a library such as React is that Qwik components run both on the server and on the client by default. However, in real-world scenarios, there are various situations when you'd like to run code only on the server or on the client. Don't worry though, Qwik provides simple yet powerful mechanisms to accomplish such things. Take the server function for instance. This one is an interesting case study since it allows you to create a function that always executes on the server while providing an RPC mechanism so that the client can retrieve the information resulting from the server function call. How is Qwik achieving this complex task in such a seamless manner? Let me explain. The server function wraps a function and returns an async proxy to the function. The server directly calls the wrapped function, and an HTTP endpoint is created and exposed to the client. Then, on the client, using the endpoint, the proxy function invokes the wrapped function via fetch call. A little bit earlier, I mentioned that Qwik allows you to build full-stack apps. Again, if you are up to date with the most recent trends in web development, this should not come as a surprise. Just like most meta frameworks, Qwik exposes an endpoints-based implementation that allows you to pretty much create complex REST APIs running seamlessly on a node environment. The path listeners are defined via directory-based routing solution, another industry standard at this point, and they can be consumed by your components. By the way, these advanced routing and data endpoints capabilities are part of a meta framework built on top of Qwik called Qwik. This is rather an opinionated tool with a bunch of other useful features such as nested layouts or file-based menus, and the chances are you'll work with the entire Qwik framework whenever you want to get started with this stack. Just as an FYI though, these endpoints are not a one-size-fits-all solution. While powerful and flexible, they are best suited for prototyping and smaller projects. When developing for large applications, my suggestion is to still stick with a proper backend technology in order to better address topics such as security, performance, and scalability. One thing that might have caught your eye in the code is the heavy use of $signs. I'll explain the role of these in a second, but first, I'd like to ask you to help me fight the big bad YouTube algorithm by liking this video and subscribing to the channel. Okay, so one of the more annoying bits about Qwik, especially for devs first looking into the framework, is the use of $signs. While inconvenient at times, this is the mechanism that allows Qwik to do all its under-the-hood work and optimizations to reach such impressive performance metrics. In short, the Qwik optimizer splits your application into many small lazy loadable chunks called symbols. The $sign suffix is used to signal both the optimizer and the developer when such a transformation occurs. So, a component can be divided into multiple such symbols, and these symbols will be loaded on the client lazily only on demand. To better visualize this, consider a component with an on-key app and a click listener. When the component is first rendered and sent to the browser, there is no reason for Qwik to send the event handlers as well. Maybe the user will never trigger any of the events. Therefore, the two listeners will become two separate symbols stored in separate files. The component sent to the browser will contain special links called Qwik links pointing to those files, and whenever one of the events will be triggered, the chunk of the data is downloaded and executed on the client. Don't worry though, it has been asked before, and no, the initial download of the chunk will not cause lag or slowness in the app. Of course, besides original features such as resumability or the Qwik QRLs, the framework comes packed with all the features you would expect from a professional, production-ready tool. I have a couple of other videos on my channel looking at other features in detail, but please let me know in the comments if you are interested in more content on this subject, especially now that Qwik provides various stable integrations with libraries such as Auth.js or the Builder.io visual headless CMS. Until next time, thank you for watching.